everyone. In this video series, I will be revising linear algebra, and while doing so, I will try my best to explain whatever I can. So let's start. First of all, let's talk about vectors. What are vectors? So, vector in physics we know has direction and magnitude. For example, in physics we have velocity, acceleration, force. They have their direction as well as they have some magnitude. For example, v vector, this has a direction and a magnitude of v. So, but in computer science, vector is nothing but a ordered list of numbers. In computer science, like we have an ordered list of numbers, that's 1, 2, 3. This is a vector. But in mathematics, vector is just an abstract concept, and we have some operations on vectors like vector addition, scalar multiplication. We will talk about that later. So first of all, vector is written like this. This is a 2D vector. It has x component and a y component. This is our x component and this is our y component. So the length of the vector is written like this: a1 squared plus a2 squared. This is the x component squared, y component squared. On coordinate axes, we can also visualize vectors. So a vector A is something like this, and it has a y component, x component of x, a1, and a y component of a2. So two vectors, if we have two vectors, we can add two vectors and we will have a resultant vector. For example, if we have a vector in this direction, a vector, and a b vector in this direction, on adding, we will get a vector like c vector in this direction. So if c vector is equal to a vector plus b vector, and if a vector has an x component of a1 and y component of a2, and b vector has an x component of b1 and y component of b2, then the c vector will be equal to a1 plus a2, a1 plus b1 and a2 plus b2. So all we are going to do is add the corresponding components of the two individual vectors. So the resultant vector will be c. We can also take this vector, and I want to take only this. We can take this vector and keep it here, so that the tail of b vector matches with the head of a vector, and the resulting vector will be c vector. Okay, so now let's talk about 1D vector. What is a one-dimensional vector? One-dimensional vectors are nothing but we can represent them just on a number line. For example, if we have a number line like this, let's say we have 1, 2, 3, 4, 5. So let's say we have vector 1, which has a length of 2, and another vector has a length of 3. And so on adding these two vectors, we will get a vector 5. And as we have seen, these vectors, these were the 2D vectors, and they are just nothing. We are using a 2 cross 1 matrix to represent it. For example, this is a 2 cross 1 matrix which has 2 rows and 1 column. But these 1D vectors are 1 cross 1 matrices. And don't confuse these one-dimensional vectors with a scalar. For example, this is not equal to this. Okay, now let's quickly talk about scalar multiplication. So if we have a vector, let's say 2 and 2, 3, we can multiply it with a scalar 2, and it will result in 4, 6, which it will result in another vector which has an x component of 4 and y component of 6. So if you try to visualize this, what's happening when we multiply a vector with a scalar, let's say we have a vector a and we multiply it with a scalar, let's say c. So a vector times c equal to, let's say, a vector b. So this b vector will be nothing but this will be the a, but it will be more scaled. I mean, the b vector will look like something this b vector. which is C times A vector. Now, if the C is negative, then this B vector will be in opposite direction because it has just opposite direction of what A has. So now let's talk about unit vectors. So what is a unit vector? So unit vector are the vectors which has direction, but their magnitude, their length is just one. They have a unit length. So we have a unit vector in x direction, and it's called I cap. It's usually written as I cap. Okay, so it has a length of one. It has a length of one, and similarly we have in y direction we have j cap, and it also has a magnitude of one. Um, we can actually, first of all, let me say that I cap these unit vectors have a mag length of one. That's why we call them unit vectors. So if we try to write this in vector form, we can see it has an x component of 1 and a y component of 0, and j cap has x component of 0 and y component of 1. Now, if we have any vector, let's say a vector, we can actually write this a vector in the linear combination of these unit vectors. We can write a vector can be written as like, let's say this has an x component of 2. We can write 2 of I cap plus, let's say it has a y component of 3. So we can write 3 of j cap. So this vector can be written as a linear combination of I cap and j cap, and that's why these are called the basis vectors. Basis unit vectors, and I and j specifically are the standard basis unit vectors. Now, actually, any pair of vectors can form a basis vectors, except in two cases. The first case is if both the vectors are in the same direction, then we cannot use these vectors to write other vectors in the combination of these two vectors. For example, if we have A in this direction and B is also in another direction, in the same direction, maybe let's say different magnitude, so we cannot write any other unit vector in the linear combination of these two vectors because the span of these two vectors is just a single line and it does not represent the whole plane. We can write like p vector is its constant times a vector. So we can also say that these two vectors are linearly dependent. They are linearly dependent. Also, there's another case when we cannot use these vectors to represent any other vector, and that's if both the vectors are zero vectors. So this was case one. So if both the vectors are zero vectors, we cannot use these vectors to represent any other vector. I mean, this won't work. We can just use these vectors to write any other vector because these are just zero vectors and this span is nothing but a dot, the origin. So apart from these two cases, thus if two vectors are not linearly dependent, for example, we have a vector A and vector B, so we can write any other vector in the linear combination of these two vectors. So the span of two vectors is just this 2D plane in which these two vectors lie. This is a span. This whole plane will be the span of these two vectors. That means any other vector can be written in the linear combination of A and B. We can write any other vector in this plane in the linear combination of A and B. For example, like we have a vector C, we can write C vector as some x times B vector and y times A vector. Similarly, if we have three vectors which are linearly independent, let's say we have vector 1, vector 2, and vector 3 in this direction, if these vectors are linearly independent, then the span of these three vectors is the whole 3D space. This is the whole 3D space, but in this case, it was this 2D sheet. Now, we can see that these basis vectors that we talked about, these basis vectors are always linearly independent.